All right, we're going to go ahead and, we only have an hour, so we're going to go ahead and get started and just let people still trickle in. Okay. So my name is Desiree Mackey. This is Brian Mackey. We are married. Just get that out of the way right now. How many people have been to one of our classes in the past and already knew that? Okay. All right, anybody never been to either one of our classes? Okay, well, this should be interesting. So we very rarely get to speak together. While we have similar interests, our work just doesn't tend to intersect. So
which is ironic, because we actually met at Autodesk University.
Yeah,
that's how geeky we are.
How many people knew that?
At a speaker social.
We met at the speaker social right here at AU. So we very rarely get to do this, so we're excited about it. But I just want to warn you, how many of you guys have children? And have you noticed that after you feed those children, they go from being this nice, calm little package of cuteness to something that literally runs around the room, and he does the same thing after he eats. So,
and we're after lunch.
Yes.
So if I start doing laps, you guys will understand why.
All right, so when we were putting this session together, these examples came from work that I was working on, and often when I actually get to work on a project instead of working on everybody else's projects, I do that work at home or in the evening. And inevitably, because Brian is a super geek, he and I end up working on things together. So that's how this happened.
I think she just comes home because she wants help. That's what I think.
Okay. So we also had a problem with doing a class together, is that we had an argument over whose computer to use. How many people have heard me say the number one thing we argue about at home? Keyboard shortcuts. That's not a lie. So if you notice, we have two computers up here. So we solved this problem. So we can stay married by the end of the session, hopefully. All right, so this session is, I'll just skip right to that, about two conceptual structural models. So I'm assuming generally most everybody in here is structurally related or will not be offended if all the examples are structural. Okay? All right, good. So the two examples are a pedestrian bridge that is just about to go into construction, so real project, and then an arena roof that didn't ever really get off the ground. So we got both ends of the spectrum. But we went through this conceptual phase, and with the bridge, we actually went through the CD phase. So I'm going to take you guys through how we did, well, we'll take you through these things of how we did these models and these families. All right, so I have to kind of remind myself what's up here. All right, so this is the bridge. It's three-span at an intersection, and it had a very specific client-desired look to it. It is kind of sort of a secret, so, but it's like they're in construction, so it's not going to be secret much longer. So the look that they wanted was like this inner and outer spiral of this bridge, but they didn't know much more about that. They didn't know exactly how they wanted the angles of the members to be, and they didn't know how it would look as it got bigger, because each of the three spans are slightly different. So they wanted to be able to sort of stretch and bend and change how this looked to decide what it would be. But that's kind of a complicated piece of structure to stretch and flex and bend and be able to do a quick feasibility study saying, hey, yeah, that's going to work. Because the structure of the bridge is entirely aesthetic. So there's no like hidden structural members. We just used what they wanted with the helix is what we came to call it. So we wanted a flexible model. They wanted to be able to flex absolutely everything. So we had several iterations of this guy. Then the roof was a little bit more simple in the scheme of things. What we got from the client was a CAD file that he had blocked out sort of the shape that he wanted in a look. And he goes, well, I started doing this and realized I don't even know if this is buildable. So I want to send it to you guys, and can you do a quick study on this for me?
Just for a show of hands, how many structural engineers actually get input from their architect that early on? Sorry, I thought it was pretty.
So then we kind of took it one step further. We're like, you know what? He wants to sort of take this into conceptual iterations. So we said, well, how about if we just give you back a tool that you can flex and play with, and then when you've come to all these iterations you want us to check, send it back. And since we built it, we have ways to get our structural information out of that. So that's what we did. So we're going to start with the bridge, and it's kind of probably be fast. I hope we'll get through all of it, but please feel free to interrupt and ask questions. We tend to talk quickly, so this should work out just fine. All right, so starting out. So the general approach of the bridge was it screams repeater, right? It repeats through this inner and outer helix. But it also needed to be adaptive because it needed to stretch and bend, and those angles potentially needed to stretch and bend. So we started with a 2-point adaptive component that we brought into a host family and repeated it, and it sort of iterated from there. Then structurally what we wanted was to be able to get those coordinates out of the model, and we found out recently that a lot of our analytical software talks to Excel really well when you just have coordinates. And so we can dump from Dynamo into Excel and dump those coordinates right in and do a real quick conceptual feasibility study. So that was the goal here. So we started out with this 2-point adaptive component, which I was like, all I need is a square. I just need a representative element. I don't even care if it's structural, it's a generic model, whatever. And Brian, fortunately, has developed a far more exciting 2-point adaptive component that he's going to show you in a second that ended up being really useful for this bridge. Specifically, the way the outer and the inner members needed to intersect. Think about insertion points when you're thinking about like structural framing. You have the top, bottom, left, and right. It became evident real quick that we needed that sort of functionality. And so we essentially made a structural beam out of this 2-point component. And then you want to switch?
Sure. So, of course, Desi just said she needed a rectangle family. Yeah, I don't play that game when it comes to adaptive components. So for me, I'm going to cover a little bit what it was. I've been dealing with adaptive components since they came out. I've taught a few sessions on it. And anybody here besides myself find adaptive components extremely quirky? Right? So some of the tools I use to eliminate that. So what originally started with this family I had is I just have this rectangular profile. And I don't know if it's, I was deprived as a child from playing connect the dots. I don't know if my parents deprived me, but I really, when I'm doing adaptive components, like to host points on points on points on points and connect those points with lines. It's the most stable way I've found for dealing with adaptive components. So in this particular example, I'm not going to really go into it, but I have my 2 host adaptive points, and then these points are hosted to that, and they're just set up with an offset. So I just have an inside here, you'll see that in the offset parameter, right here, I just have a parameter for like half width, etc. So I like to host points on points to get things to accomplish. Yeah?
When you say you host on points, do you mean you're hosting on a plane? One of those planes?
Yeah, so when you're hosting a point on a point, you can always come up here and hit the set button, and then using the tab key, you can get to any one of the 3 work planes that a point has. I am also slightly a type A personality. She might say more than a slightly, but usually what I will also do is name every single one of my points, because then it'll tell me what the host point is. So as I start going through, who here names their reference planes? Y'all should, because in 2018, you can actually see the name of the reference plane in the project environment. I blogged about this last week, so that's a huge tip for me. But I do the same thing with adaptive component families. So normally, if I'm going to host a point off of another point, they will all be labeled. So I'll say like point 1 left, point 1 right, etc. So when I'm looking at an additional point, that will come through. So what I ended up doing is I take that rectangular family and I host it into then another adaptive component family. And what I have found with adaptive component families that's very buggy is if you host an adaptive component into an adaptive point that's nested, more than likely it will screw up. Anybody put a rectangle family in and it starts rotating and twisting and you're like, what? Well, that's the reason for that. I cleaned that up, we're being recorded. I usually say something much harsher than that. So what I have found is between my 2 adaptive points, I will draw a reference line. And then I will host a point, again, my connect the dot deprivability from my parents, I host a point onto that reference line. And when I do that, that eliminates the twist factor happening in your adaptive component family. So yeah, sure, it would have made much more sense to take this rectangle and just host it into the middle of, into the adaptive point family, but more than likely that will blow up. So I take a point and I literally host a point on this reference line. And what's great about a point hosted on a reference line is it also allows you to then move that point from either the beginning or the end of that reference line to deal with it. So since I usually want that point to be where the adaptive point is, I always just parameterize this to allow me to move that point in and out. And I just call it control point. So I can just go ahead and move that point in and out relative to the length of the line. I don't really care where it is, just for the ease of editing this object. So I don't want it on the end because then I've got a point on top of a point when I'm creating and editing the family. So that's the only reason why I have that. And I did have to make a tweak to this family because originally when we put this into the bridge, we got to the corners and we had the big void in the corners, and graphically we just wanted to overlap them for very quick ease. So I did redo this, and basically this point then has this point here nested onto it, so I could do a positive or a negative offset to get those to move in or out. So if I wanted to go through here and make this move to the other direction, so kind of like a structural framing, remember, with your start extension or cut, they changed it. It used to be start extension, you could do positive or negative, but anyways. So I basically built that into this. So I nested that family in there. Then what I found over the years is I'm constantly having one that's got an insertion point in the middle, insertion point in the left, and I kept, I had like 15 different families. So I decided, of course, to add a little parameters to this, where if I just simply hit a checkbox, I can position this stuff all around with offsets. So therefore, I've got one family that I can have an insertion point in the middle center. I could have it in the top center, top left, top right. So basically, I can add 9 insertion points to this simple family. Just starts really coming into play, especially it was really beneficial in this project here, but also with just simply the adaptive component families where it becomes a pain. Has anybody ever put one in, and on this adaptive point, it hosts this direction, on the next one, it hosts that direction, and you're like, ah! So rather than loading 3 different families, I can just simply change the insertion point by checking that box. And it's just basically a simple conditional statement saying, hey, if that's checked, be half of the width or depth or height or whatever it's going to be. So it's not that confusing. And then since I nested in that adaptive component family, so I've got the 2 here, what's nice is, I'm going to go back one step here. In that rectangle family, these are model lines. So they can't be reference lines, they are model lines. So since you can't use a profile in an adaptive component family, you have to use an adaptive component family with model lines in it. So those are model lines. So what's great about it is once I got the rig all set up, I can then just select those 2 nested families, say create form, and I got my rectangle. Okay? So it's kind of a little bit roundabout way to get into this and start going through there, but that's really what this family allows us to do.
Okay. So then once we had that done, we built this. This is the host family. And it's got, is it? Yeah, okay. So it's got, it ended up with 8 or 9 lines, reference lines that are divided, and then this adaptive component is hosted on it and repeated. And so we parameterized absolutely everything about this, the number of divisions and the length of it, so we could have the 3 different segment lengths. And then the architect wanted to know, which you'll see when Brian opens up the family, the architect wanted to understand what were the angle of all of the members, how is it going to look. It was very about how this is going to look from the ground, essentially, and as you're driving under it and as you're walking through it. So we have a lot of, everything is flexible. It made for kind of a complicated family. And then, so what we did, and what I did so many times, there were so many iterations of this. There was, let's see, does this work? So this bottom member, they wanted several different iterations, one where it slants and one where it's horizontal, like perpendicular to the bridge. So there's sort of this spiral look, but what they found out, or the architect found out, is that if you sort of continue the spiral, so each element has an angle, from the ground, it doesn't quite look like that. It's not the aesthetic that they wanted, so they wanted several different ones. This one, I think, is the final one with the bottom that's perpendicular. So that's the outer sort of helix. And then there's these inner pieces that run the length of the beam, or the bridge. So then I think that's it. So here's the family.
Okay. So I kind of, as I said, using adaptive component families, went along the same approach to this as I did going along with that 2-point repeater. So I still have, in this case, they're not adaptive. We ended up at the very end just adding a length parameter between 1 and 2. Or no, they still might be adaptive. I don't remember. We went through so many iterations of this.
I think this is an earlier iteration. Towards the end, it got really complicated for the architect to be, or even the project team. I was rebuilding this and then placing it for them by the end because it was just so many things were parameterized that it was hard to flex. It was hard to understand, which I kept saying that from the beginning, but they wanted it that way. So what we ended up doing once we had like the length lockdown is I started pulling that functionality out of it. So at the end, this adaptive component was 1 point, and it was kind of just set length.
Yeah, so here they are both adaptive components, adaptive points, excuse me. So again, between those adaptive points, I drew a line and I hosted a point onto the line, just like what you saw I do in that. Again, for all my adaptive component line-based type families, I do that. And again, here we come into, I've now got that point there. These points are hosted to the vertical surface here with an offset. These points are hosted to these points with an offset. Then once I did that on each end, I connected those points with a reference line. Okay? And then once you have a reference line in there, you can always select that reference line. And for those of you who don't know, you can just come up here. We obviously didn't do it with this control point, but you can just come up here and just say, I want to divide the path. So they also, I don't remember when we did this. Did we do this in 16 or in the older versions of Revit, if you had two lines together and divided the path, it would divide them independently. But that's been fixed for this last few releases where you could have 6 lines together, divide the path, and it ignores the fact that there's a join. So really nice feature when they added that in. It's kind of like the old AutoCAD. Yes, I said AutoCAD, the old AutoCAD divide command. But so I can come in here and say, okay, I'm going to go divide this path, and then you can also then parameterize it. So do you want to do a fixed number or a maximum spacing? And we did go back and forth with that theory on here. Are we going to go with a fixed number parameter, or are we going to start going through with a quantity parameter? And we ended up going with just fixed number.
Which was really actually kind of difficult because the client wanted we'll call them the panel points of the bridge, so one revolution of this helix, to be the same in each of the 3 segments that were all different lengths. So there was a lot of coordination between that and a lot of formulas, which made me happy, about figuring out how many divisions it was and then how many, what the length was. So it was actually a little bit complicated.
Well, it also even made it more confusing because they wanted 6 divisions, but we were technically, because of the angle, skipping like 5 bays to get it to happen. So like, oh, they need 6, but we got to skip 4. So if they want 6, we got to type in 40 or something weird. So it was a little bit confusing. But so then once that was done, I just take that that rectangular 2-point family and I just go ahead and place it on here. So for those of you who haven't played with repeaters or divisions, if you just do 1 and you say repeat, it repeats it along every single one. But like I said, and I forget the number, we had to skip a few.
Yeah, it's 4.
I don't know.
It's 4 with the flat bottom.
I'm going to pull Emerald and pull it out of the oven in a minute and go bam! So, I mean, we're right near one of his restaurants. I figure that's appropriate. But the other thing that you'll start to find, and I actually want to do this one slightly different, is when you have that on there, it also matters the way you pick when you're going with adaptive component families. So this one, it didn't really matter. You can kind of start seeing on here. So sure, I went one that's to the middle right, but if I take both of these, why I have the family that allows me to change it. If I go from like the middle right to the bottom corner, because this one I went up and this one I went down, you can see they're on the opposite sides of that line. So understanding with adaptive component families, directionality, the way you draw things becomes very critical. And when you have to delete things and redo it in like 3 weeks, you're like, crap, did I draw them going this way or that way? Inevitably you'll get it wrong.
Well, it sort of puts in your face what we all preach to the people we work with is always model in the same direction, do it consistently. But when it sort of comes up to you, like here, I'll model this 2 different ways, so it's going to behave in opposite directions, you suddenly have to really adhere to those rules, and you're immediately seeing why. So that was challenging with this, to get them all, especially once you got all the members in there and which point am I grabbing, and it became complicated.
So with that, what we started doing is we then just selected this, and then you can go up and say use the repeat command or the array looking icon, and then since we had 3 spaces between it, it will continue that going across. So we had to do this going up this side, across the top, down the other side, across the bottom, and kind of make that spiral effect going around. And that was what we did just to start, just to kind of get the concept to show them, hey, here's what the spiral pattern will start to look like.
So, you want to pull it out of the oven?
Yeah.
So what happened, what was kind of interesting with this is that we built up all of these, so there's all the angles those are just reporting parameters so they could understand what the angles were.
She's talking about these dimensions here. So then the client said, well, we have a logo that has a whole bunch of angles. What angle are you? So we can compare that to the logo.
Yeah, we're not joking.
We're not joking. That was real.
In fact, if you orient it just right, you might be able to guess who the client is, which I think I've removed from everything. So if you accidentally see it, pretend you don't know it.
And if you guys from that client are listening to this recording in a year, we had your permission to show this.
I did ask for permission. So what was interesting about this, we built in all that parametric behavior so we could go from, we ended up calling it bays, 13, 16, 17, 18, 19 bays for the different lengths of the bridge. But we found out, and it's a really strange behavior, and I started asking other people that have done a lot of repeaters if they've noticed this behavior. And we don't know if it's something that's repeatable, but it was for us, is that if you change the number of divisions, so that you want to add, say go from 13 to 16 bays, the division is centered along the repeater path. So I want to add one complete revolution to the end. So instead what it was doing, if I added one complete revolution, was adding a half to the beginning and a half to the end, which was annoying. So what this ended up being was 3 separate families that, of course, they couldn't decide. So I think I have 10. I have like everything from 13 to 20. So there's several. So that was kind of complicated. So this is the final family here.
No, this isn't the final.
No, it's not?
So the other thing about this, too, that we had, that I ended up actually changing and building into these families, back to the family, I'm going to go to it, is when we put it in there, we realized, oh, we've got to do the inner spiral and the outer spiral. When I had this set up, they also were then going to start having some additional offsets. So that's not the button I wanted. So back in the original family, I went and tweaked it even more so, because on that rectangular 2-point family, I showed you guys how I have basically the left, right, center checkboxes, but we had to go in there and also start adding in an offset, because in some of those cases we wanted to, I'll make it bigger than that.
So now it looks exactly like structural framing on a family, right? You have the Z offset.
Yeah,
and the
you
Y
get your
offset.
Z offset. So I also started assisting in that as well. So when I told you guys literally I had this point and then I hosted this point onto it, I then had to redo it all, rehost another point so it would get shifted off to the side. So I could shift that with a positive or negative number,
Right.
because we really needed to come in there and start playing with the
Right.
original family that we had. We were sitting there thinking that, oh, okay, so we'll just have this one set of repeaters and everything will be on it.
Yeah.
The final family, we ended up having like additional lines to host the inside members to, the outside members to, the floor members to, the roof members to, etc. So it wasn't so simple, but we had this set up just to be able to start coming through.
So that in the bookkeeping part of it that was difficult, you'll see they have the exact same number of divisions along each of the paths. So because they had to line up. And so that's what became like a bookkeeping nightmare, is that this first member went from point 1 to point 2, and then this one is like 0.5 to 0.6 or whatever it is. But so I'm going to switch back and I'll show them the profile. So this is the finished section, I guess, of the bridge. So this is, you can kind of see the gaps in here. So this is what eventually caused us to have 8 divided paths instead of 4. And then those offsets to kind of, like all of these members there are hosted off that inside point. So the insertion points. And then this guy, I think this point we have for the inner helix, you can call it. So then there's floors and the metal deck and such. Now it looks like a structural element. And it wasn't green, it's just that so you can see the outside and the inside. Okay, now the castings. So one of the way they wanted to fabricate this was to have each of those, I'm going to go back here, each of these corners, so as, each of these corners as it comes around this corner, but think about the way that looks with the bridge. So the way the corner comes across and it's at an angle at the top, and then the side is at an angle there, so you have like a compound angle, is that the word I'm looking for? It's angled in more than one direction. So this is actually quite a complicated geometry. And so they were going to make this out of castings, and so symmetry was an important thing. We wanted to have as few templates as possible. So we spent a lot of time, it's an amazing amount of engineers standing at a table trying to visualize exactly what this was going to look like and how many unique cases we had. And we got it down to 2. So with the bottom, where the bottom angled element was perpendicular, and then the top, where the top was angled. Because if you rotate it around, like kids' toys where the spatial awareness, if you rotate it around, the angles end up being symmetric. So then we thought we would model these so we could see it in the project itself, but then we got a little bit, I've used the geeky term again, and we thought we could 3D print this. So we went above and beyond to create this, and part of the impetus to wanting to do that was that we were having a really hard time communicating how difficult this geometry was to our client. So they didn't quite understand that as you come from an angle to an angle with 2 elements that are exactly the same size, this little part here is going to get bigger. You can't just turn that corner and keep the same size and everything. It's not a tube, that you just sort of bend. So you have these sort of tapered, bigger edges, and they had all these sorts of requirements on how if you're looking on it, they didn't want to see the element get fatter. So it was difficult. So I spent all weekend, one weekend, And it was pretty much brute force, just massing these things out and getting the angles and going back, and I'm like, okay, this is what they're going to want. This to clean it wasn't what they wanted. I think we rebuilt these 3 or 4 times, and that's when I'm going to 3D print it, and I'm going to bring it to AU. So then when we decided to do that, we needed to make it hollow because we didn't want a solid piece, because currently those pieces are solid, and then we had these little filleted corners. And I was having a horrible time getting the final sort of aesthetic with the rounded corners and everything. And so Brian, brilliant idea, he's like, well,
don't judge me. I'm just saying, before she makes this statement, do not judge me.
He did it in AutoCAD.
Well, to clarify, I use the Inventor add-ins for AutoCAD because I do not have Inventor. But
yeah, so he finished this in AutoCAD, and then we ended up not 3D printing it, so I don't have one to show you. I'm sorry, that would have been awesome. It came in way over budget. Surprise, surprise. So they brought a fabricator on really early, and they actually took all of our stuff and all of our families and used it, so I felt good about that, but they sort of took over this situation from us. So here's the Revit part.
so here is that Revit join. We actually ended up having like 30 different variations of this because they kept saying, oh no, that we don't like that. So that was the other thing that the offset parameter started adding to that angle is even though we were all on the same nodes, they wanted to play with the way this would mold together, so we ended up having to tweak where those point locations were, which is why we ended up having to have an additional repeater on the inside of the outside repeater for the way the bottoms and stuff were coming in and the offset values. But this one really isn't intelligent. There's not any parameters to this. What really was difficult on this is trying to get, like we said, everybody to understand this. So we just ended up basically coming in here with a whole bunch of rectangles and saying create forms. And this rectangle, create form, etc. to get this. We really, really, really did try to fillet these corners. Revit would not do it. We couldn't do it with voids. We couldn't build it into the curves. Revit just simply would not do this. Trust me, I spent like probably way too many free time for her company trying to get this to happen.
We could do it pretty easily at these places, right, where the profile is constant and back here. But in this sort of tapered, which that was huge amounts of conversation, how far should it taper from this kind of thick knuckly looking thing to back here? We had a really hard time here, and then don't even talk about that corner. Like, how do you, I don't even know.
So we did actually take this and export this out to DWG. And if anybody's never actually been in AutoCAD, there's the great 3D modeling tools that they stole from Inventor. So when I was back in AutoCAD, I didn't open that because it was pretty brute force because I don't remember AutoCAD. But when we did do that, we went through and basically hit the fillet command in AutoCAD. It did it seamlessly. It did it really well. And AutoCAD also has a hollow command, which this one is not hollowed. I didn't need it in Revit, but we did that for the 3D printer. So AutoCAD, we used the Inventor fillet tools. We used the Inventor hollow it out, so the whole thing was hollow. And we did send that to the fabricator for them to be looking at for 3D printing. Yeah. But I did import the DWG back in and explode it. Yes, I exploded it. But I did end up with basically just this direct shape type object in there. And again, this was more for just to put into Revit to give them the graphics of this is what you are going to need. Because these square, uncompound, uncut things was freaking everybody out.
Yeah, so they weren't getting those nice smooth corners. So we actually put these pieces inside the project, and we just plopped them right on top of the bridge.
In no fancy way.
Yeah.
Plop, align, 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 align.
Yeah.
They weren't adaptive. They were just, hey, they came from AutoCAD. There you go.
Okay, so then now we have our pieces, and then came the structural part. So I was thinking that all we really needed was coordinates, because we can kind of set up the analytical model to know which members go from which nodes to which nodes. So I just needed the coordinates. So I thought, well, I'll just grab all the generic modeled elements and get their endpoints, because I'm thinking like it's a structural framing element, right? So what I found out very quickly is that when in Dynamo, now I don't pretend to be a Dynamo expert. I know just enough to, do a few things like this, so I'm sure you could learn a lot more from Carl. But so what I found is I was having a really hard time dissolving that generic model that had all these profiles, especially the bells and whistles that we had built into our profiles, into one simple curve with endpoints. I was getting multiple curves. So think about every edge on that, all the way around the profile on both sides and all the way along the center line. So it was not working for me. So what I ended up doing is I made a little tiny, I called it a node, and I put it on the repeater at each node. And then I was in control over which coordinates I actually cared about, and I didn't have any duplicates. So that's what I ended up doing, is created this little, looks like a little ball, put it in the family, and I was done with it. And then I had a relatively simple Dynamo script, this is the entire thing, to pull out the coordinates of those nodes, pull it into Excel, and dump it into our analytical, which was a very simple process once we got there. So I think, Brian, are you going to run it? And while he's running this, get your QR scanners ready. But we found out today,
Literally at lunch.
literally at lunch, if you have an iPhone, your camera is a QR scanner. We didn't know that. Did you guys know that?
So new iOS, your camera is now a QR code reader. I did not know that. That was a new feature of the iOS. I learned with new iOS, so yeah. So this is Desi's highly sophisticated adaptive component family.
It's a circle.
Just
not
to
square.
throw out. It is adaptive, so if I go into X-ray, you can see inside of here, there is an adaptive point in there. So it's an adaptive point. She then drew a line and said, hey, create a solid. So very highly complicated thing. But what ended up happening
No judgment, though.
I don't even think you parameterize it. It's just a circle.
No.
See, I couldn't not parameterize that. So then she just put it in there and used the repeater command just like normal and basically repeated it where she needed to. But again, it was the same scenario. Put it where they're intersecting. So one of those little bit of a pain in the booties, put it in, make sure you're on the right one, and set that up.
Yeah.
And then with that said, once she had those inside of there, there was a Dynamo script that was written that says, hey, you're looking for that family, and we're just going to go ahead and run this and export this out to Excel.
Super simple.
So then she got an X, Y, Z coordinate of every single one of those nodes.
So, and it's not as sexy of a spreadsheet as the other one that we'll see later, because this is all the analytical software wanted. We just wanted something we can copy and paste, and it doesn't need to be pretty. So that's how we did it. And I've now done this. We created this kind of workflow to get these simple points out, and I've now done this on a lot of projects. I'll show you a picture of another one at the end. And a lot of different iterations of it, with points or endpoints or columns or whatever. It's turning out to be pretty handy. So take the time to make a little Dynamo script to pull some coordinates out. And then the QR.
Yep, there.
So I'll make sure I'm out of the way. So if you scan this, you can look at what the bridge looks like. One is just the one family, and one's the whole project. And we sent this to the client. Well, I just thought it was going to be. I thought it was going to be cool. Like, I'm a structural engineer sending them, Inkscape stuff. Like, they're going to think this is so awesome. They're going to love us. They were not impressed. I was like, I emailed you a QR code and you could see the bridge. Isn't that awesome? And they were like, yeah, we didn't really look at it.
Yeah, so the one on the left was directly taken from the project, the family, and the one on the right was taken from after the project was done, quite a few months later, and they put the whole bridge together. That one actually came from the bridge.
Yeah, so try not to hit your neighbors as you're looking up at the bridge.
Yeah, especially the first one, because I did it, I wasn't even thinking about it like under the bridge. It's like, well, they wanted to see it from a person's perspective, so.
Well, and that's what was really helpful with this. I don't do a ton of this structurally because it's not generally something that's super helpful. But this was because they were really concerned about how the structure looked from specific viewpoints. So underneath being one. Well, wait till I just don't see cameras in the air anymore so you guys can scan this and look.
So yeah, and this was done using Inkscape, so I don't know if anybody knows, I've been preaching Inkscape, I think since they were in beta. I've been using it for a few years now. I like Inkscape, I like the ease of Inkscape, and this was shortly after they came out. The family one was shortly after they came out with these Save the Panoramas. So, but we were walking around it, through it, etc. with the file. So, and then I think most of the cameras down now. So, and then this is what their final bridge project looked like. So you can see these are the adaptive component families, which really aren't adaptive anymore. They're basically just, hey, we've got the points
stagnant.
Inside of there, and then they just use standard Revit structural modeling tools for the stairs, the structural columns, everything else, etc. But that is the crazy custom bridge for what the client really wanted to look like. And so that QR code on the right, I threw a floor in here, and that was the this model just up in Inkscape. So I think the grass comes out gray or something. We literally didn't spend that much time on it, but it was just to let people know, hey, here you go. And I believe we also gave them an executable so they could walk around it too.
Oh yeah, that's right, we did. That's probably why they weren't impressed. I was like, I don't really care what color the ground is. I'm looking at the structure. There's no trees. There's no people.
There's no road.
Yeah, okay. What are we on now? Everybody good? Got it? Okay. All right, let's talk about the roof, which is a little bit shorter because it's kind of a lessons learned from the bridge onto the roof, and it's a little bit less complicated, which is kind of surprising since it looks like that. That looks kind of complicated. But it does repeat. So are you looking for that blog?
Don't have it.
Okay. So back when, oh gosh, I don't know when it was, 2012, 2013, somewhere in there. It was a while ago. I don't remember exactly what came out, but we were playing with curtain panel by pattern families applied to structure to create like space frame, really fun stuff. And we wrote a blog on it a few years back. And then when this came through, I think this is our, this came from my model. But what the client gave me was this DWG that had sort of a surface look to it and had some lines in there like this, like, oh, could the structure look like this? Because again, the structure had an aesthetic requirement. So when that's the case, you have to be really concerned about if it's actually going to be feasible. So thank goodness they asked. But he started to do this, and he wanted to know if it was feasible. And it made me think of, probably because it's so repetitive, of the space frame thing that we messed around with a few years ago. So I came home, and I was like, do you think this would work? And so it did. So this is what we did. So again, the 2-point adaptive component, same exact one. Then we used the curtain panel by pattern to create different pattern options and made some custom different patterns as well. So the idea is to give back a tool to the client to toggle these patterns and look at different things. Then he could give back the iterations, and I get the coordinates out of it into Dynamo, just like we did with the bridge. So the overall roof is a mass and then a divided surface instead of a divided path. Notice the theme here. And then we hosted that pattern on that divided surface. So here's the pattern. I think this is one of the custom ones that we ended up doing to get one of the looks that he wanted. Just simple triangle. And what we did was hosted that 2-point adaptive component that represented my structural pieces here to here. And originally the client wanted like different tapered lengths and stuff, but we didn't actually get that far to build that into it, but that could have been interesting.
Well, another thing we did realize on this too is we put the 2-point adaptive family on all 3 corners. And then since it was going over a warping edge, you get this one square here and this one square here, perpendicular to the face it was hosted to. So we ended up with all these little V things. Yeah. And so that's why then eventually we're like, yeah, we just need to see if there's a structural feasibility to it. Yeah. So that ended up getting yanked out really quickly. And here's that blog post, as you said. It was back from 2012. But this is something that came back. I think we were still in Vasari back then, but I was doing curtain panels by patterns. That's what it was. And because this also talked about when Vasari had the sliders, right? Because I was showing people the sliders. So we had just been playing around with this curtain, space frame, because Desi had some other project that needed a space frame truss. So I was, of course, it was
the table in Grasshopper. It was back in my Grasshopper days.
Yeah. So I was geeking out on this, just creating this up, and then of course we played with it. So you can feel free to go check that out. And then the Vasari wind analysis. So that was a blog post he was talking about. But back here, so we started off creating this curtain panel by pattern. So for those of you who haven't noticed this, when you started just with a new template for a curtain panel pattern base, when you do that, if you select the grid, you can then change it to be the different types of patterns. So it was just as simple as just timming this and grabbing, we grabbed one of the triangles, I think it was just the triangle flat, and then that basically just switched you to having the 3 points. So once you have those 3 points, with that adaptive component rectangular family I had, it's very easy then just to go from point 1 to 3, 3 to 2, 2 to 1, whatever, and place that in there. But like we said, what we found out really quickly, we literally loaded that in and like double rectangles were everywhere. So then I was starting to parameterize, we would do one and not the other. We'll just put them on one side and we'll swap the panel. And Desi's like, no. Well, I just need points.
Well, yeah,
Stop geeking out and let me get my work done.
Because that was the thing. So as we applied this to the surface, like this triangle on this side could have another triangle right next to it, so this element would be duplicated. But all I was going to do is get the coordinates of the points dumped into a spreadsheet, and then I could cull the duplicate. So I was like, I don't care. Let's keep it simple. So we
ended up loading her advanced adaptive component.
Because we ran into the same problem. Hey. So we ran into the same problem, right? Is that we had all these complex curves with that 2-point adaptive. So I put the nodes in there. It's a really simple solution, but heck, it worked. So who cares? All right, so here's the mass. And this was surprising. This took the most time of anything in this project.
Thanks, Carl.
What? So what I did is I took their DWG, tossed it into the mass family, and I traced, for lack of a better term, 3 curves. I wanted to keep it really simple because the client wanted to be able to adjust this, but he knew he wanted this overall sort of rhombus-looking shape. with 2 corners and then 2 curves. So these 2 curves on the end, I guess it's easier to see over here, or maybe not, I don't know. These are flat. So this holds the elevation, essentially, of the edges. And then the center defines the curve, but it's curving, like it's a dome, kind of. So it's curving in all these directions. So it was a little bit of, well, for me, it was a little bit of a mind bender to try to figure out how to define that with as few points and as few curves as possible and still match his overall shape. So 2 flat curves with 4 points each, and then 1 center curve with 3 points each, or 3 point. And then once that mass was created, so very simple mass family, did a divided surface. That's this, what you're seeing. And then you can edit those divisions, so the client could then edit how many U and V divisions he wants and apply the pattern. I think that's, yeah, you want to show them the mass family?
All right, so inside of this Revit family is the mass. So this is the DWG mass that they did get from the architect. I don't remember what software they were using, but they gave us a DWG to do that. So we, like Desiree said, just brought it in, put it up at the top, and then we had to go through and start pointing it. So if I grab the surface, the form for the divided, and I go into X-ray mode. So what we ended up doing to start off is exactly like what Desiree said. We kind of put their thing inside of here, and we just put some points down to somewhat represent where they had their AutoCAD file. And then once those points were placed, we just did a spline through points on those, and I'm going to go hide this AutoCAD file. So once we had those points placed, we just did spline through points on these. Same thing over here, and then same thing up here. And it wasn't really set to where it needed to be. And then they shipped this off to the architect. So look, here's something you guys can play with. We have this family available to us. So if you go into X-ray mode, grab that point. I'm not going to adjust this because I don't think you guys want to sit here and look for the next 15 minutes at Revit Think. But take that point, move it up and down. All of that divided surface will start to go through it as well. Yeah. So then they could give that back to Desiree, and all they do is run their Dynamo script to get the Excel points.
Yeah, and it was a pretty easy tutorial to give. Like, press 3 buttons and do it in an email with a few screenshots of how to get to that place and be able to sort of push and pull those points. It seems to be like an intuitive approach to it, so that worked pretty well. That was a good communication tool.
So once that was done, then it was just a matter of going in, let me get out of X-ray mode here, and just taking that and dividing the surface. Figuring out the quantity of divisions was the other difficult part to get what they wanted. So once that surface had been divided, you've got your U grids and your V grids, so just playing with those. I don't even think we made that parametric for them. I think it was
No, yeah, we did. I sent them the family. I didn't even put it in a project. I just sent the family and gave them a quick tutorial of how to use it. And
with a disclaimer of if you jack with it, it's going to take forever to adjust. But
well, and I suggested that just once they kind of play with it and they like it, do a save as, play with it until they like it, and just send me back 10 files or 15 files or whatever ones you like. We'll do some feasibility studies and decide which one's the optimal solution. And we noticed there was some odd things. This is divided a lot more than I think what they ended up with was far fewer. But there's some kind of funny things along the edges where it couldn't quite resolve that particular pattern. We showed them how to swap out the pattern for different sort of looks. But we weren't really concerned about, I mean, we're really early on here, right? This is very early in the project, so we weren't real concerned about what that looked like. And besides, I still had this point and that point, right? So in the analytical software, I could just put an element there if I wanted.
So then once that was done, I'll go back, hide the AutoCAD file. Just went through and we had, let me turn the surfaces off. So that was the divided surface, then you just did the division, and this was just the family. I don't think I have the right family with all the little nodes. And then I forgot to open up Dynamo, and then
that's okay. So,
ran the Dynamo script.
Yeah, so we'll go back to the PowerPoint for the Dynamo thing to show you too, but we quickly found out, and why Brian didn't flex this for you right here, is that those adaptive components inside the curtain panel by, I can't, curtain pattern by
curtain pattern by panel. Curtain panel by pattern.
Yeah, I do numbers, not words. The combination of those two things, and then depending on how many times it was divided and how many different iterations, the turning of this was ridiculous, like minutes, which in my time, I was just like, I hate when I can think faster than my computer. So we felt like it wasn't, we were trying to think about how our client was going to be playing with this. Doing one tweak and sitting for 5 minutes while it thinks is not a good conceptual tool. So what we decided that we didn't need each of these members to have a thickness, because I don't know that he cares, nor that we necessarily know what those sizes would be. So we ended up pulling out the two, the mass part of the 2-point component and left just the line. So that really simplified the geometry, and then it just ran like gangbusters. And then my poor little adaptive analytical node was no longer necessary because what I had was a line with endpoints. So we made the model run faster and then also benefited the Dynamo. So we're going to switch back to the Dynamo real quick. Made the Dynamo go faster. So that's kind of what is here. I think this is one of the final concepts I kind of liked. And so when we switched it to the line, it kind of went faster. And so here's the Dynamo script. Pretty simple. This one is a little bit more fancy because I could. So this is just the endpoints of those elements. And then, oh, good. Hey, we're on time. You want to show the Dynamo?
Yep. So then here's that Dynamo script. A little bit empty.
Hey.
Yeah, well, you know me.
So I get.
Dynamo tip. Did you know you can hit control?
I was just going to tell him this. Okay, I was going to say that.
Personality.
But you know how he found that out is I get a text in the middle of a workday one time, and he goes, "Do you know that Control L in Dynamo will line up your nodes?" I was like, "No, why would I know that?" It was a long time ago. I was like, "How did you figure that out?" I was on a really boring call with a client, and so I opened up Dynamo, and I held down Control and pressed every other letter.
I thought everybody did that.
Who does that?
I thought everybody did that.
He also right-clicks on random crap in Revit just to see what happens.
But anyway, so that's the Dynamo script. It's very much the same thing as the other one you saw before, except for this one, it's just a little bit different because you had to get the, you were doing it off of lines, correct?
Yeah, so I used the lines and then got the endpoints, which is where I was going originally with that bridge, but I was just getting too many lines. And although it did seem to be regular, like give me this profile, and the center line, that was just way too much list management for my taste to get like every fourth item or something. So the node was a far faster solution. But this one, I just had lines and endpoints. This one's a little bit sexier. So it's got...
You know what you need to deep when just more data equals sexy. I'm just saying.
Yeah, so here's all and this was different analytical software between the two projects. So then was just we copied and pasted into a second spreadsheet actually for this to do some kind of churning of this data, make sure we didn't have duplicates and things like that. But mostly it was really easy to get into the analytical software.
That was one of the problems in the bridge too, is when we were trying to use just the adaptive component families, you were getting duplicate points because you had a line running across here and another line coming up to that same point. And then originally when that had the inside structure, then since we were offsetting the members graphically, we then had like 4 points there.
Which is why the node was such a good idea. Okay. All right, so I have one more. Oh, good, we're doing well on time. So I have one more little, I'll have a picture for you in a second. So I learned a few things from these different things. The 2-point adaptive component that had all the bells and whistles ended up being really key for that bridge. But it was the whole model was so parametric and had so many things that they wanted to flex. It ended up being not very user-friendly for anybody other than the people who built it. So that was a little bit challenging. But it didn't end up, it is getting built. It did end up being used on a project. We didn't have to like throw it away. It turned into the actual model. So that was nice. And the fabricators liked it, so we did something right. Then for the roof was pretty simple. The big lessons learned there was to keep the geometry more simple than I needed it, just to keep the speed up. Because if what you're going for is that conceptual tool to get some real quick iterations, it doesn't make sense to have your computer be churning. Then the Dynamo scripts sort of evolved. And I've done this on a few other projects now, and I've done just use the little node or use the endpoints. Or what I found out is if you're using actual structural elements instead of generic models, which is part of the issue here, is that structural elements have those analytical lines, and you can pull those into Dynamo and just forget all about your geometry. And your users have to model it correctly, but you immediately have those lines and you have those points, and that turns out to be quite a good tool for us later. So here's another project that we're working on. We do some funky stuff at my company. Everything from arenas to sculptures is what I like to say. So this is a little sculpture that we're working on. I'm not entirely sure how this is going to stand up, to be honest, but we'll see how it goes. So we've been doing the same thing, is trying to figure out where in this little man we're going to put the structure, and then be able to pull those points that are not regular at all and do some analysis on it. I think that's the end. With a few minutes for questions, if you guys have any.
And if anybody gets up and leaves, we're going to say the typical thing. Please remember to fill out the surveys.
Oh, yes. Yes, go ahead.
What software are you using for the structural analysis?
So the question was, what software
thank
we're
you.
using for structural analysis?
Yeah, so we use pretty much everything under the sun. So depending on the project, we might use something different. For the projects that you saw today, we used, try and remember which was which. RAM Elements was one of them. And, well, what did you say? SAP. Well, yes, I think it, God, what was it? No, not RISA, unfortunately. We don't have RISA anymore. It's really sad for me. I love RISA. No, but RAM Elements is a big one that we use a lot for this sort of thing. We do use a lot of SAP, ETABS, those sorts of things. What? Robot? No, not yet. We've looked at it, but I would like to look at it more, because then I wouldn't have to go through Dynamo and Excel, right? So it was, the analysis software was really dictated on what the engineer wanted to use, and then we just sort of adapted it to what we could. Yes?
Can you comment a little bit on what your thoughts are integrating some of this conceptual designing in maybe Format or Project Practice?
So the question was, how can you incorporate some of the schematic structural design into Format or Project Fractal?
Format would be interesting. Our clients are still in SketchUp mostly, to be honest. But we have encouraged them to try out Format just for its communication. So I'm interested. Haven't done it, though. We can't get that's the truth, honestly. We can't get our clients to get off of SketchUp. But I would love to. I'd love to give that a try, because there's some real good possibilities there. Fractal, I haven't had an opportunity to really play with it yet. But I know I'm knowledgeable enough about it that it would be really fun, but we weren't necessarily optimizing anything other than somebody's aesthetic preferences. So I don't know how we'd build that in. Maybe in iteration 2, where we were looking at cost or something like that. Maybe that would be applicable, because that would be fun. We just don't I don't know if you guys, other structural engineers in the crowd, I feel like we don't get to solve those fun solutions. I mean, we don't iterate on our structure to see which one would be prettier. It's just not what happens. So
I have an answer to that question, though. So I have one client who's working really well with a structural engineer, and they're using anything from SketchUp, Grasshopper, Rhino, Revit, something else too, maybe Format. I don't think it was Format, but they're actually using Flux. So they're using Flux, and everybody's exporting their data out there. And it's actually being much smoother than I thought it was going to be. So we've got all the information up in Flux, which for those of you that know, it's kind of like Autodesk Fusion, where everybody can extract out of it. So there's SketchUp model extracting a little bit of data, then taking that into Rhino or Grasshopper, and then bringing that back and putting it into Revit. So it's actually working fairly well. And the nice part is that the architect owned the Flux project. I don't think it's called a project, but whatever. They own that Flux project, and they just invited the structural engineers, et cetera. And it's actually working pretty well to get these iterations back and forth really early on in the conceptual phase. And it's not as simple. It's all planar angles, but the building's got like 13 different steps all going up and down like this, and the whole building's canted. So it's a lot of work going on, and it's working really, really well. And I know the structural engineers also taking that out into their analysis program as well.
this little man is actually in Rhino too. So we've brought this back added Rhino into the mix of this workflow.
Do you think you could have set up the bridge model using Dynamo and out-of-the-box member components? Or do you think, given the complexity it had, it just had that parametric set?
I thought about.
So the question was,
thank you.
Could you use Dynamo for that bridge to get that bridge going with direct structural components?
Yeah.
This also was when there were still issues with the structural components, because you started this in 16, I believe. And Dynamo had some issues with structural components a lot of times. I think that was still like in Dynamo. I think it started in 0.8.
There still are, yeah.
So,
it really wasn't feasible, I don't think, because we did think about it. Because think about how you would set that up to place all the members in space and then repeat them. And then once we started thinking about how repetitive this pattern was, it felt like a better tool for the job to use the adaptive components and the repeater functionality in Revit. So could you? Absolutely, I'm sure you could. It just seemed like a path of least resistance to go the other way.
Well,
but once we figured out how those repeaters kind of flexed funny, maybe that would have been...
Well, all different variations too. Early on, we got this created and were able to hand it over to the structural engineer, and all they were doing is playing with links, etc., and it worked really well for them. It wasn't like you needed to know anything crazy. It was, you know, I like Dynamo, but a lot of people freak out over the spaghettiness of it, and if I just have a Revit family with a couple parameters on here, that's something they're
this was before Dynamo Player, for sure. And yeah, that would have been a little bit overwhelming to hand, here's this, and here's a Dynamo script that you have to flex. So user interface at the end, maybe. But now with Player, it maybe would have. So could I do this now instead of 2 years ago? Yeah, good question. There was one more? Yeah. What is the height? Oh my gosh, you're quizzing me on something. I don't know.
Well, let's see. The projection screen is about 40.
I know it's large. It's under 100, I would say. It's a ground. It's on the ground versus we do lots of stuff, sculptures and things that are like on cruise ships. They're a little bit smaller scale, but this one is on the ground, so it's probably bigger. I don't know off the top of my head. I'm sorry, but large. It's not my size.
And for the recording people, that's 5 feet tall.
Hey. Anybody else? Well, thanks a lot for coming.